This is M9, Linear Regression Lab. So for step 1, I imported libraries. I imported pandas, seaborn, and matplotlib.pyplot. And then I imported a dataset, so I imported pandas as PD. And I made the file read Excel, but instead of the default, read CSV because it is an Excel SX file, not a CSV file. And df.head, and it imports the header of each row, each dataset type, each column and row. So it has, there's a header, does the header. In the columns, you can see the rows, it has 0 through 4, and then it has 26 columns. And then step 3, you can see here is it's car body. As you can see, including the car body type. It adds the car body type, okay. And then this one, it's to remove non-numeric columns in car ID. So non-numeric ones, which is the car name, front, driveway, door number. It's anything with numerals. And then and then you make sure you have the car ID. So there's the car ID right there. Car ID types right there. And then we have assign the variables. And then split, train, and test. Assign and fit the model for linear regression. Then evaluate the model. And move into that. Then we predict the new car price. Car equals. And then all this is make prediction. And then an array. And then it turns into an array. So the new car price is $15,214.20 is the average. And then the graph actual versus predicted. And it bases off most cars. A lot of the cars fall into the 5,000, 10,000 range. Majority of the cars. Some do fall into 15,000. Then there's some outliers 40,000, 25,000. Some in the 20,000 range predicted price. But a lot of them fall in the 5,000, 10,000 range, even actual and predicted price. But the average is just at 15,000, which makes sense if there's cars that are $40,000. There's a couple $40,000 cars, one near 40,000, some $30,000 cars mixed in. But then the majority of them are 5,000, 10,000, which with outliers that really make it a lot higher than most cars actually are.